All right, so yesterday we learned a couple rules about congruence of triangle theorems, and one of them was the side-side-side theorem, which told me that if I have two triangles such that all three sides of one are congruent to all three sides of the other, then the triangle is congruent. And the name of the triangles was important, that they were in the right order based on the congruences. So AB matches DE, AB and DE are the front letters. BC matches the EF, BC second, third, EF second, third. AC matches DF first and third, first and third. So when we name the congruences, it's important how we write the congruence statement out. All right? And then we had, of course, side angle side. Same idea, different information known. So we have side, angle side, something like that. Doesn't matter which two sides, just so long as the angle between the two sides, like that. So side angle side look like that. I'll just use the same letters, A, B, C, D, E, F. So let's get triangle ABC is congruent to triangle DEF. Right, those are the two we learned yesterday. We did have side-side angles show up in an example problem. That's not a valid proof. You can't show that two triangles are congruent by side-side angle. That does not guarantee congruence. All right, but side angle side and side side both guarantee congruence. Again, that's what we dealt with yesterday. Getting a couple new ones today. First one's angle side. And when you see angle side, you're going to get angle congruent to an angle, a second angle congruent to a second angle, and then either one of the two sides not between the angles. Doesn't matter if it's this one and this one, or this one and this one, but the one not between. So AB and this side, EBE and that side. Okay. Now it is important. Notice I went from here to here, so this matches this, that matches that. So if I go from this equal angle to that equal angle to that side, I couldn't have that. This side's opposite the angle with one mark, that side's opposite the angle with two marks. That's not the same. So whatever angles are equal, these are equal, go to the next equal, the next side over should be the same for the triangle congruence. So that's angle side, and that's triangle ABC is congruent to triangle DEF again. And then the final one we're going to deal with today is called angle side angle, and that is two angles and the included side. Okay, side angle side, two sides of the included angle. So when you see the word included in geometry, typically means something between two other things. So angle, side angle, the side in between the two equal angles is the included side. So triangle ABC is congruent to triangle DEF. And for general triangles that aren't right triangles, these are the theorems for congruence. This is it. All right, this is how you show triangles congruent. Any one of these four scenarios would allow you to do that. So when you're trying to prove congruences of triangles, this would be your list of criteria. One of these four things has to happen. So just like yesterday when we saw some triangles, what else do we need in order to show this? That's kind of what your brain should be going towards. If I'm trying to prove congruent triangles, I've already got a couple sides congruent, well, I've got either this one or that one to go with. If I have a couple angles congruent, then I got one of these two. If I have a side and an angle, I could maybe get this one, or this one. So depending on what you know, it's kind of leading you towards one of these four congruence properties. If you look at example 1, a technician installs a cable from a cell phone tower to the ground. To pass inspection, both cables must be the same length. Does the installation meet the cable length requirement explained? So if we take a look at what's going on here, obviously we got a triangle happening here. We got this segment drawn in. It goes from the tip of the triangle down to the ground at a right angle. We can see that these are both the same angle up here in the corners. The ground we'll assume is a straight line. We're going to have a perfectly straight ground there. So if this is a right angle here, 90 degrees, that leaves 90 degrees left over here, so that's also 90. So if I just start naming some stuff, let's just put some letters in here. Let's call this A, B, C, and D. Doesn't matter what letters you pick. And it says explain, so it's kind of like those show problems from yesterday. I want to demonstrate what I know. All right, so first off, I'm going to say that I know that angle ABD, which is this 52-degree angle, is congruent to angle CBD, which is that 52-degree angle. I know that angle ADB, let's just say ABD. ABD, not ABC. ABD, CBD. All right, ADB, this 90-degree angle is congruent to angle CDB. All right angles are congruent. They have the same measure, definition, congruent angles either way. So if angles have the same measure, they're congruent, definition, congruent angles. If angles are 90 degrees, they're congruent. All right. Finally, looking at BD, so that's angle, right? But notice BD is the same piece in both triangles. I got triangle ABD and triangle CBD. They both have this side BD. And I know BD is congruent to itself by the reflexive property. Right. And that's pretty typical. A lot of times you have these geometric shapes drawn where there's a shared side. If there's a shared side, then it's going to equal itself. It's going to be congruent to itself, so you immediately get that side. So if we take a look at what's going on here, we have an angle side angle congruence of the two triangles. So I know for a fact that this triangle, we'll call it ABD. Again, my first congruence name doesn't matter, the second one does. So however I listed the letters here matters, it doesn't matter. But then when I come over here, I've got to get them matching. So D matches D, so D goes last. B matches B, so B goes in the middle, which means that AC must go first. So ABD is congruent to CBD. And once I get congruent triangles, the requirement is the cables have to be the same length. Once the triangles are congruent, all the corresponding pieces are congruent. And if you take a look, AB, which is the first two letters, and CB, the first two letters, represent corresponding sides then. So I know that this side has to match that side because the triangle's congruent. So finally I can say that AB equals CB, or AB is congruent to CB. Okay. Does this installation meet the cable length requirement? They have to be the same length, so the answer is yes. Explain, there's my explanation. In all these problems where it says to explain, just give me a list of all the statements you would have in a proof. That's an explanation. Again, if it's not saying to prove it, I don't need the actual formal proof. I don't need statements and reasons, but at least give me the statement column. I want you to be thinking through the process. I'll believe that your brain was going towards the proving ideas if you do that. That demonstrates a good logical sequence of events there to allow us to make that